Amy, can you put that onto all web view, as long as you go along the bottom there? Yeah. Good. Maria, can I good to go?
Go ahead, Robert. Yeah.
Good afternoon and welcome. Thank you very much for all of yourselves who've joined us today. My name is Robert Clements. I'm the project lead for HEATR. We want to have a third and final webinar today looking at energy education and behaviour change and sustainability. This is probably one of the most important areas we want to cover, looking at this communication work within HEATR. Education and behaviour change is a very key element to trying to deliver change, especially with their key stakeholders, with their householders. And recent projects were, as one small example, we're putting pilots into houses in Handy Heat and into our projects in Oma. And one of the key things we found is, for example, whenever you fit heat pumps into houses, the tenants immediately notice a difference in the temperature of the radiators, which is the way heat pumps work, where they give out constant low heat and heat up your house slowly, and then they retain the heat with the level of insulation. At the start, the tenants didn't like this because it was a change from what they had, and they were not able to dry their tea towels. But after 3 to 4 months, they now completely get it, and they're completely sold on the idea that the house is warm, and the radiators, they do not need them to go and dry their tea towels. And there's a clear example of how, once you let people understand it and see it, they then accept it, and then they change the behaviour. But the learning point for us out of that is we need to have more education, and at the start of the project, to try and people understand what they're doing. Because a key statistic coming out of Imperial College and the Committee of Climate Change is over 60% of people will need to be educated and empowered to deliver behaviour change. It is not good enough just to put technology into people's houses. You have to bring people on a journey. You have to educate them and empower them that they make the decisions and the right decisions for themselves. So that's a wee bit of the context of why we're having this conversation today. Today we're going to look at 3 guest speakers, and we'll just go through them in order. We're going to look at the hybrid lab from Oulu, from Finland. We're going to look at ARC Healthy Living, which is the first healthy living centre in Northern Ireland, based in Irvinestown. And then we're going to speak to Charles Young, who's going to look at EV education for ourselves. The key is looking at the overall solutions for heat, health and well-being for rural, sparsely populated areas in the MPA region. Our aim here is to educate and inform rural householders on the key issues and the technological advances. Again, as I said, this is the third seminar, and we will be looking forward to the final conference next month, which we'll give you details of at the end of it. Now, if we just go through the agenda, Amy, there, I'll just introduce the first speaker, which is Saku, who's a lecturer in energy technology from Oulu University in Finland with applied sciences. Saku is a lecturer in the Department of Civil, Energy and Building Services. He's going to give us a quick talk about his hybrid lab, which includes the above mentioned inside Oulu, and it's the state of art of hybrid energy lab in Oulu. Saku, over to you. Thank you very much.
Yeah, thank you, Robert. And yeah, I share next my screen. And just a second. Now it should be on. Can you see my slides?
Yeah, thanks.
Yeah.
Okay, great. Yes, my name is Saku Leskelä. I'm working as energy technology lecturer in Oulu University of Applied Science. And thanks to invite me to tell about this our nice fine hybrid laboratory and where this hybrid name came. So basically we have 4 different laboratories put together, so we are kind of independent, but work together. So there is automation, energy, HVAC, and also electric power laboratories. And like you see in these pictures, there is this left up picture. There is solar panels in the rooftop and also the wall mounted. And below that is our control room. Nice visual place. And the third in the right side is our student loading our pellet boiler screw conveyor there. Okay, shortly content. So let's see the location where we are. Then jump to this energy laboratory part and how we transfer the heat. So district heating network. Just a couple of pictures of HVAC laboratory sites, and then I shortly say a couple of words of our digital twin, and let's be a short summary in the end. So the location, so Oulu University and Oulu University of Applied Science is located in the same Linnanmaa campus area. Pointed out, so it is here, and this yellow box is our hybrid laboratory, and in the left side of picture we located in the Oulu, so it's kind of middle north south from Finland. Okay, this is floor plan for our laboratory. Sorry, it's finished, but we have about 1100 square meters space. And for the left side, we have this energy laboratory. I will today speak mostly of that, but also top one we have this power laboratories. Middle we have automation laboratories, and the right side we have the HVAC side. And further on I will tell a little bit more about how we are connected this together. So here is this is a screenshot from our website, which is available in this address. Actually, I can after this present I can upload this also to the chat box, because this is available for everyone, and it's very easy to use. So it's kind of Google Maps. You all have used Google Maps, so you can drop you in and start to travel around this hybrid laboratory. And there is also some videos and material included in the info buttons. But yeah, this is a previous project, was this ESS lab project, and in that project we investment about 2 million euros for the equipments in the laboratories, and it is most of EU money, but also the local companies was involved, and it was ready about 2020, and we start to education, but because of the COVID, the billing rate it's not so high, so we have kind of a minimum effort, but looking forward, so next autumn we can fully take everything out from the nice equipments. Here we have some let's say key equipments what we have. I can, for example, point out the four of those. So we have solar collectors in one wall of the energy laboratory. We have vacuum type and plate type collectors there. It is connected to this hot water tank. Then we have a bio-oil boiler, pellet boiler, and electric boiler, which is also connected to hot water tank, but as well as in our district heat network. So this is kind of the main main components to heat. And also one separate is this geothermal heat pump, and it is own water tank there, so we can also educate from that. Then I took a couple. We have quite a lot of measurements there, and I took something data out it. So if I go shortly, this is this plate type solar collectors, and this first picture there is this green color it's fluid from the collector to this hot water tank, so the temperature. And the yellow line is fluid from the tank to the collector, so we can monitor, for example, the temperature difference from flows. This below diagram is showing this power, so kilowatts what we get out, and the right side we have this bit larger diagram. This is cumulative ways for energy. So we start. This is a week ago, one day period. So 24th May. In the morning it was 655. Okay, let's say 656 about, and its end about 664 kilowatt hours. So in that day we, let's say, earned about 9 kilowatt hours. And I took the same data for same day for this vacuum type solar panels, and there is a big difference, small difference. It started a bit earlier, and it's continues a bit later on, and if you take some measurement from this kilowatt hours, it's about 10.5. So in that day we got a little bit more kilowatt hours with this vacuum type solar collectors. But okay, let's go back to this floor plan, and this is this district heating network. So I speak earlier how we combine these laboratories together. So in this energy laboratory we create the heat. We have heat boilers and solar collectors. We have this district heat network ends to this HVAC laboratory area where we use the heat, for example, radiators, HVAC units, ventilation units, and hot dog butter as well. I have next slide some pictures of those, and also we can adjust the temperature, so we can monitor kind of real life. So district heating temperature can be very, let's say, 70 to 115 temperatures, and for higher up level we have a superheater there, so we can achieve this 115, which is the temperature of the district heating water if we have let's say minus 32 degrees Celsius outside. Okay, and then couple nice pictures. Let's start with the left side. So here we have these exchanges, heat exchangers, what we saw in last picture for 4 pieces. So the latest one there it's for radiator. So this is kind of three floors building, so to speak, and one task is to balance the network there. And then there is 2 hot water exchangers in the middle, and one for the HVAC units, what we actually can see this right side picture. So there is the pipes go to the heating battery, and this is the machine ventilation unit, what we create the fresh air for this hybrid laboratory area. Okay, then just couple words of the digital twin for district heating network, and it also includes this boilers. So different boilers, also the hot water tank, and this district heating network. This is kind of fully monitored with our digital twin. And there's maybe one good example how we can use it. So if we take this, for example, pellet boiler, I say that if we heat it up, probably it's take about 4 hours. But this digital twin, we can basically monitor the all same functions in 5 minutes. So we can run the simulation much faster and get the results there. So it's kind of some cases it's time saving way to operate with this digital twins. And also the power network side, we have a similar digital twin, but today I don't speak more about that. This is made by MATLAB and Simulink used, and we are making lots of work together with Oulu University, and actually Oulu University it's created this digital twin. Okay, and then short summary, nice picture of our laboratory. There is kind of power side and heat side, and this is kind of so easy way that what we have and which direction. So we have this general local grid what we can use, but we have also own production, own battery system, so we can separate our network from this local grid. We have electric car loading places, geosource heat pumps, and also this heat sources what I show you earlier, and also maybe a couple of words of the future and the next steps. So there is some plans that at least I hope that in some period of time we can also add something hydrogen, so maybe some well cell in the system, so we can create the power, but also use the waste heat in the hydrogen side as well. But yeah, okay, that was pretty much all I want to present in this time, and if I see the chat box, I think there is at least nothing yet.
Okay, Saku, can I just thank you for that? Can I just ask maybe one question? I just don't know if a question from Robert. Just want to come on first.
Yes.
You use Finland, and just for context for sort of our local listeners, Scandinavia has adopted low carbon heating quicker than we have. They've got a higher level of energy efficiency because of the climatic conditions. Have you found much resistance to going from fossil fuel to low carbon systems from people's behavior or prejudice, for example, or have you found any resistance? Because today we're looking at people's behaviour and how we're moving people onto a decarbonised system. Have you found any sort of resistance whenever you've been, you're roughly about 5 years ahead, whenever you've been moving towards decarbonised heating?
Yeah, I think the question was of decarbonized heating. So try to avoid CO emissions, and I think that this renewable energy sources, it's nowadays, and I think this for example solar heat and solar panels it's now in lots of conversation, and there is asking for education.
It's definitely the Scandinavian countries would be well ahead of Britain and Ireland. Robert McCreary there from Energy Saving Trust, you had your hand raised there. Robert, had you anything just to ask or add on the sort of intro or Saku's presentation to date? Okay, we'll leave it to the end. If you have any questions, guys, just stick them into the chat box. Now, just as we move across here, Robert's, well, your hands up. If you have any questions, Robert, just come back to us, mate, would you? We're now going to hand over to Charles Young. Charles Young is in the newly formed Atlantic Technological University. He's basically down the west coast of Ireland. He's from the Donegal campus from Letterkenny. He's going to talk to us about electric vehicle engineering, and he's pioneering basically EV engineering again through Atlantic technology. So Charles, it's over to you. And again, if anybody's any questions, just stick them in the chat box. And if you have anything at the end of Charles, we're going to have a talk. Thank you, Charles. Over to you. You're very welcome.
Thank you, Robert, and thank you, Saku, for that insightful presentation. Yes, so my name is Charles Young. I'm a mechanical engineering lecturer at Atlantic Technological University, Donegal. And I'm going to talk to you today about our move to electric vehicle engineering within our department. So to give you a bit of an overview then of what we're going to talk about, I'll just run through my background to begin. I'll give you an overview of our department as it was and our current position now. We'll look at course diversification options that we considered when looking to expand what we offer. Obviously, electric vehicle engineering was one of them. That's why I'm here today. And we'll talk through just those course offerings that we've created. I'll touch on collaboration efforts that we've had with local institutions and indeed industry, with the mention on research there finally. So it's about 16 pages. Hopefully it won't be too painful. All right. So to begin, me then started off, I suppose, the interest in engineering began due to my father, who was an electrician, and he seemed to be able to fix anything that went. So I followed suit, I suppose. And then after that, I went to my second level education. I actually went to 3 separate institutions here. Okay, secondary school, grammar school, and technical college, and I'll come back to that anyway. Where usually most would just see one. And then after that, I went on to my third level education in University of Ulster, Jordanstown. So I was fortunate to get sponsored by AVX and Korean for that first phase of the third level. And then I managed to get a PhD opportunity with Rolls-Royce, and that was a 4-year duration. And then after that, I took a KTP associate partnership, and that was with the University of Ulster McGee again. So staying with the University of Ulster the whole way, and that was for 2 years. So that's a 10-year time frame. Since then, I went on to just work for myself for a year, helped my brother set up his own turbocharger reconditioning company. And then from that point on, I've been working in ATE Donegal, and that's been 9 years now. Again, the motivation for sharing this is just, as I was saying there, what I've learned alongside 3 separate and distinct groups of people here. And what frustrated me and saddened me was I wasn't the brightest of them, and I wasn't the most gifted. And yet I managed to progress in academia and industry just on account of an interest level in a subject area. So and then after that, then all of my higher third level education was combined with industry and academia. So I got to see both sides of the fence, their frustration from industry's perspective with respect to academia, and vice versa, academia's frustration with industry. So I knew after I completed my PhD that this was an area that I wanted to invest in, and I wanted to make it open to anyone and everyone, I suppose. And hopefully that'll come through here just in what we've achieved recently. So, yeah, I'm from the Department of Electronic and Mechanical Engineering. Pre-2000, we typically offered core electronic engineering and mechanical engineering. These were level 8 programs, 4 years in duration. You could opt out in year 3 with a degree or stay for the additional year, which afforded you an honours level qualification. We offer a practical approach to a degree, and that differs, I suppose, to maybe other third level institutions, which might be more academic and research oriented. What we struggle with is student enrollment and student retention on account of that kind of demographic that we would account for or cater for. And what we also struggle with is just on the fact that we deliver an engineering-based subject, which you'll appreciate if STEM-related, science, technology, engineering, mathematics. They're hard to recruit for because, yeah, engineering is hard, I suppose. That's what you hear. So what we find in mechanical engineering, or what we, yeah, is that numbers are cyclical, depending on, obviously, as we all know, what's going on around us. If I give you an example of what we would have across the 4 years, in first year, I would expect 40 students to enroll, probably about 30 continue to sit exams. By the time we get to second year, we've probably only got 20 students remaining, you know, and I would call that the kind of the light bulb year group, you know, because then they realize the opportunity and really get engaged. Year one's fun, you know, and you can't really expect a huge amount there. But in year 2, you really start to see the students invest a lot of their time in their studies. And then obviously then we would lose 1 or 2 as we progress through to year 3, and that's when the student would get the opportunity to leave with a degree award. And then we're always hopeful to try and retain them then for the last year for the honours degree level, and we typically see about 13. So we constantly climb there. And more so, what was of greater concern at this point was the fact that we've continually seen a steady decline in uptake in STEM-based subjects, or our mechanical anyway. And an academic year of 2017-18, for example, I had less than 10 students in front of me in year 1. And when you look at this, if you start with 10, what you're going to get in year 4 is going to be grim. So we decided then that action had to be taken, and we had to think of diversification. So as a department, we conducted a SWOT analysis, and again, now just the benefit of having the education to inform us in terms of what we should be doing. And then we also conducted another analysis just on ourselves with respect to options for course diversification. So within those options, you know, you'll see biomedical, data analysis, like these are all just opportunities for us to diversify into, in addition to our mechanical and electronic offerings. And we had manufacturing engineering, marine, renewables, agricultural, chemical, automotive. So they're all up for grabs as we've seen it. But for each of these, we had to consider resource investment. We had to consider as well what level of interest this would be to the prospective learner. Again, we're looking to attract the students to these hard subject areas. And we also wanted to consider level 9 progression feasibility of each, because we as an Institute of Technology were progressing to a university status, and therefore research level work was expected. So we needed to select a subject area that we were interested in as well, because we would inevitably be embarking on this research or this journey with our learners. I've highlighted 3 significant ones here, as you'll see, are those which we have continued to run with to a degree. So biomedical, we've subsequently created a course there, and it's an electronically based biomedical degree, which differs slightly to those in existence out there on account of the fact that there might be more predominantly mechanically based. We've got a campus in Killybegs, which is a big fishing port, so we are investigating marine still. It's a vast area. There's loads of opportunity for niche or diversification there, so within marine. So we've just got to continue working on that front. But the one that I'm here to talk to you about is obviously automotive, which was a difficult one for us to strike, because we evolved as a department from the motor vehicle industry. Look, we used to teach motor vehicle in actually in the same floor that we're currently teaching out of. And a revisit to this area had been attempted in recent years, and it was not unsuccessful. And also it's associated with lack of employment opportunities locally, because there's no big car manufacturers. And then also you've got your boy racer stigma. But what was to become apparent at this time was this revolutionary phase shift to electrification or electrified vehicles. And I suppose, you know, at the time that seemed like, wow, this huge hill. But if we reflected back to New York Main Street, say in early 1900, you might have seen a lot of horse-drawn trams, I believe whereas 10 years later, it was all internal combustion engine methods of transport that were used. So whilst, yes, this transition seemed daunting, it was furthermore exacerbated on account of the fact that in the UK there, Boris Johnson announced this accelerated change or transition to EV technology, you know, and that happened in November 2020 there, which as an engineer for me was staggering if you consider that, you know, from conception to completion for a motor vehicle, you're talking a 10-year time frame there. And so if we're looking to only sell electric vehicles in 2030, then all manufacturers need to begin this transition now, you know, or yes, well, that was back in 2020. So we had 10 years to begin. Apologies, the kids are kicking off down there. So initial the plan, and I suppose that was well captured by just one of these documents here on online from a motor vehicle mechanics perspective. The initial target was 2040, which was fine. And then when that was brought for this transition, and then when that was brought forward to 2035, then there was backlash from industry because of that significant rate. So you can appreciate then whenever it was brought forward again to 2030, that yeah, it was imminent, you know, work investment was needed here. And again, that posed to be a good opportunity for us. So if we just recap on that, we had to diversify offerings to make the discipline more attractive. Motor vehicle was deemed undesirable, so we're up against it. We were up against it. There will be, we projected an unprecedented demand for the electric vehicle skill set. I think that's a quote. We're transitioning to university and status, and then also to add to this mix, we were to see a new head of department and head of school arriving. So with respect to the pestle analysis, we had all of these factors hitting us at that time. So with that, we decided, right, let's drive electric vehicle. And then we invested significantly more time then, and then just trying to figure out a bit more about the subject area to see how successful it might be, or to see if there was merit in running with it. So obviously we've seen that there would be a global transition to EV, not just locally. Sectors, we considered sectors that needed the EV skill set: the design, manufacture, repair, and public. Again, that's looking more towards big industry, and even there with the public, that's local councils and that fleet management. The opportunities then that existed from us getting involved in that area. So obviously we would get graduate recruitment ourselves, and also locally what opportunities arose for or would be available for our prospective graduates. Business development opportunities, for example, like car battery refurbishment, like my brother, he's in turbocharger refurbishment, that's gone, you know, in time. So it's car battery refurbishment, motor refurbishment, inverter refurbishment, and so on. And we also had to consider research with the university status. We had to consider course facilitation. Obviously, you can't embark on something like electric vehicles lightly. You know, you at the minimum need a car lift, you need the car, you need all the diagnostic tools and equipment, you need the skill sets. And then with that comes the risks, you know. Is like EV realistically, like it's been here since 1998. I think Toyota released the first production EV with the technology that we're running today, or similar to what we're seeing today. You know, like, is this really going to happen by 2030? And so we took to, again, a significant, greater investment. This was like a 30-page presentation, and this is just one extract of one page from that, just all the links within that kind of time frame, in and around this need and this drive for the subject area. And then we also had to consider what would our unique selling point be. You know, is it the case whereby next year everybody's going to be doing electric vehicle engineering, or would there be any market at all? And also we've got a sister college, Sligo now, who are currently looking at AI, for example. So what would be our niche selling point? And what I made a point here was that sectors that needed the EV skill set at this point in time, I completely underestimated the need there with local industry. So then in January, work on EV course offerings commenced, January 2020 that is. And so we initiated this by developing our relationship with DonegalThe, who provide education for the motor vehicle mechanics. So they train them up. So we embarked on knowledge sharing and course delivery sharing, and also resource sharing. And that was the good, that was the benefit of that relationship for all parties involved. And we immediately identified the requirement for 2 individual courses there, One for the existing motor vehicle mechanic who has already been trained in the internal combustion engine, because what's going to arrive through their garage door is not going to be what they're familiar with. It's going to be an electric vehicle. So a completely new skill set required for them. So we decided that we would embark on upskilling those guys, and then also motor vehicle engineering then for our young aspiring leaving cert or A-level student. Again, that's just a third level entry student for the degree offering. So this is the level 7 night class again for the motor vehicle technician or the typical mechanic. The duration, this is what we created then. It would be, or it is a 1-year evening-based course. We've recruited, I think we're on our second cohort now. To say it's in demand would be an understatement. So it's flying, it's fantastic. It's subsidized by Springboard, as you'll see here. The modules that we teach on this course include management of business innovation and communications. And this was kind of the one that we thought wouldn't attract most, or would be a deterrent for some learners, you know, and it would be hard to teach and hard to justify. And can we not just do a technical module? But what we realized is that their business is flipped on its head. You know, the motor vehicle mechanic typically gets a lot of their income for a revenue from oil changes and basic servicing of engine components, and they are all gone. Now we've just got a big motor. So we've got to sit these guys down with Excel spreadsheets, and they've got to project, well, how am I going to survive this, you know? And obviously we're equipping them with the skill set too in terms of the technical knowledge there, thermodynamics, battery technology, IT systems for automotive applications, high voltage fault diagnosis, advanced high voltage fault diagnosis, because these cars have like 600 and 700 volt systems. Like the house here's got 230 or 240 volt systems by comparison. So it's dangerous stuff too. And then we have an industrial studies module at the end, where they implement the learning that they gained. So that's the evening course for the existing motor vehicle mechanic. Our age demographic on that course, well, that just passed there for the last cohort, was 29-year-olds to 52-year-olds, okay? And we filled the second one then, before the first one was even completed. But anyway, then the other offering that we have is this level 7 degree. The duration is 3 years now, and it's full-time. We started out with a 2-year higher certificate and obviously developed the third year then to make it into the full degree. And this is to create the engineer required to implement EV technology in local industry. And again, that was the one that I had underestimated, the need from a local industry. But also, in addition to that mix of craziness that you seen earlier on with respect to what was happening in our department, we also completely changed the way that our courses are offered. So we now have a common year 1. So it means that mechanical, electronic, biomedical, electric vehicle engineers all sit through the same year 1, and then they diversify off. Example modules there that they might see here would be automotive components, control systems, high voltage design and hardware, chassis dynamics, again, thermodynamics and battery technology, and then electric vehicle manufacturing, where that sees our degree students build and race little electric vehicles. So those are the 2 courses that we have been offering, and we continue to offer. What we also realized then for the night class was that a lot of those, for that age demographic of 29 to 52-year-olds, some of them might not have worked a PC or a computer in that, and so they struggled with that level 7. So we created an intermediary level 6 course, and it's a 6-month one, and it's actually more cross-border initiative as well to cater for a Northern Irish learner. And again, it's night class, precursor to the BSc level 7. And the motivation for this was so that because of this big transition to EV for that learner, in the first instance, even familiarizing themselves with the Microsoft Office package, you know, like how to work out the break even on the purchase of a tool or something like that. They might never have done that before. So asking them to do the higher end stuff for the complete transition to EV was a bit of a big leap for those guys. So we're starting low now with communications for investments, level 6, and then we also have electric vehicle, high voltage and low voltage systems. What we're also seeing is a lot of past kind of almost retired mechanics coming back to this area because they see an opportunity here. And so they mightn't have used a voltmeter for 10 or 15 years. So this is taking them back through the basics again as well, to be familiarized, because there was a lot of that. We've seen a lot of those issues with the course that we were running in the evenings already. And also then just the basic skill set to interface with the computer and diagnose faults with the vehicle, because those systems haven't changed much. And throughout the running of those courses, we've received constant demand for this, for that skill set. So we now have 3 courses then in EV. And then almost there. So then the EV collaboration that we have at present is obviously with Donegal ETB, because we share their facilities and knowledge and vice versa. It's with NWRC Derry and SWC, the Southwest College Home there as well. Again, that we're hopeful to roll out the level 6 course through them. And we've also partnered up with the lecturers there in terms of availing of the technical knowledge that Hound has kindly collaborated with us and agreed to share with us. And again, if you consider the viewpoint there, is we're hoping to take the knowledge from these motor vehicle, automotive car manufacturers who are leading out in this technology and deliver that back through and into our local industry who have to make this transition. Again, just reiterating that point, every local manufacturer that incorporates an internal combustion engine at present must change. Like, that internal combustion engine has gone. They've got to adopt this new technology that they know nothing about. So they need engineers to do that. And that's where we're hoping to, that's the niche of the area that we're hoping to fill. And finally then, just to elaborate more on that last point, we've created a master's in engineering opportunity in conjunction with local employer Terex, who manufacture crushing and screening equipment. Their entire portfolio of products must be electrified. Like, that's a phenomenal feat if you consider, like, you've got a big engine in here and that's got to go. So they have been aligning with automotive and EV technology manufacturers. Obviously, they've got a 5-year plan, I think, to try and convert this. And our work with them will be on electrifying this area of their crusher. And so the title of this work is Mobile Plant Electric Track Drives. And so that's level 9, and that's hopefully going to be the fun stuff that I get to encounter. And yeah, so that concludes where we're at as an ATU with EV. And this is just a wee picture from our expo last week, where we bring industry in to see our entire department's work. So we've got 1st to 4th years there across our department, just present for that photograph. So that's me. Thank you, folks.
Charles, thank you very much. Thank you very much for that there, just giving us a look at EV, and just going back to sort of the issue about behaviour change. I suppose on a lighter note, you're definitely the most sponsored guy through college I've ever seen. You, every time you attended college, somebody sponsored you. So unlike the rest of us pure cretins, we had to work on money power and government grants, which I know for the younger demographic, government grants are something I actually give out for education. So maybe
I was quite lucky in that respect.
Looking at EV, you know, I live in rural Tyrone, 6 miles from Donegal. The two issues for me is range anxiety and the cost of EVs. EVs are really, they're just not cheap, and that's that. There's no two ways about them, but we are moving toward 10 years. The only glide piece of hope that I can see is the Committee of Climate Change, and this is probably looks at the last 2 presentations. The Committee of Climate Change says that inside the UK alone, we're building 3 times as many gas boilers as we need for future heat pumps. And we're building 3 times as many fossil fuel cars as we need for EV vehicles. So we have got people doing it, they're just not doing the right thing. And that's where the challenge is going to be, and the challenge for universities to try and upscaling. I suppose I'd be interested, just I know I want to move on to Jenny here, but just, do you have any thoughts about the fact, you know, from behaviour change point of view, the fact Boris is now mandated by 2030 and then 2035 to finish hybrids? Surely the issues of range anxiety and cost are going to have to be addressed, because for me, going to Belfast in a full electric vehicle, I'll be fretting about from Armagh onwards. You know, really, is that you as a person working in technology, will the range increase and will it get cheaper? That's probably 2 simple questions.
Yeah, I was taken aback at a recent open day wherein we had the Hyundai Ioniq 5, and the range there was 500 kilometers, which I thought was phenomenal. Obviously now that's assuming, I'm sure, a warm day, flat land and that, you know, but the technology is getting there, so much so in fact that I tend to step back from the technology developments just with respect to battery storage or energy storage is obviously the big one there, because there's so many different investigations or avenues that people are going down there. So I have no doubt with respect to, like, when you see that enhancement or advancement, you know, happen in a period of a couple of years, you know, I have no doubt that it won't be a problem. When you mention the rural settings there, I would expect those in rural settings to be a wee bit slower to be able to avail of this technology, you know, because our mechanics are saying the same thing as well. You know, there's not as many coming into them as the city mechanic would see there. So, but no, I'd be confident then, and then obviously then with the heavier duty stuff, you've got the hydrogen option too. But I would have it.
I know, and again, I know Derry and Savannah Council is working hard to look at trying to get funding availability for EV charging, which we're working with them on that now. But I know before even that, there's 350 chargers around now in Ireland, of which not all of them work, so it's definitely that's narrow. Whereas you go over to the M6 or the M4 in England, you see a row of Teslas chargers sitting at a petrol station. It's just, we're just in a different environment, but 2030 is only 8 years away. But no, thank you very much, Charles, and thank you for that. Well, hopefully anybody's any questions, just stick them in the chat box. But again, sort of focusing on looking at the behaviour side of things. We're sort of saving the best to last. We've got Jenny Irvine, she's Chief Executive of ARC Healthy Living. Jenny is a registered general nurse. She holds a master's in executive leadership. She's a CX of ARC Healthy Living. ARC Healthy Living was awarded the Queen's Award for Voluntary Service, the highest civic recognition given to a voluntary group in 2018. And in line with Jenny's calibre and character, she answered the call and went back into nursing during the COVID crisis. So in November 2020, she put on the uniform again and was helping out whenever it was needed. So that just gives the calibre of they have it. So Jenny, thank you very much, and over to yourself.
Be helpful if I unmuted. Can everybody hear me now? Okay, that's great. Thank you. Thank you for that very kind introduction, Robert. And I'm mindful now that we're close on time, so I promise to be succinct, try and address the issues that I was tasked with and not go over anything that maybe you've heard already today. A little bit of background, where we began, and even in the topic today, as Robert's just said, it's about eating an elephant really, and the only way to start probably is a bite at a time. Our involvement with the Housing Executive in relation to rural fuel poverty was through a project called Handy Heat, and that's where we began to have this discussion. Our interest really was the definition of rural fuel poverty and looking at the policy best practice from throughout the NPA region in relation to, we were very concerned that something had to be done, but we didn't know exactly what it was and we didn't know exactly what to do. So we began to explore and research the issue. And, I suppose Robert relates to nursing, but that's, fundamentally it's based on research of what the issue is and finding the best possible evidence-based solution. So we knew what the issues were and we started to address that. The key fuel poverty indicators in rural areas we could begin to identify. We talked about energy efficiency, the distribution of fuel and the population, particularly in sparsely populated areas, children living in fuel poverty, children living in poverty, full stop. Non-gas homes was an issue at that point, not such an issue now as it in itself can be a problem, and access to low carbon technologies. Money, for us, money was a big one, and really what we saw is the cost of poor health, the cost of preventable winter deaths, and the cost of people living in cold, damp homes, particularly in rural areas. And that was unacceptable. All our work is in line with the principles of Professor Sir Michael Marmot, which is very much looking at health inequalities and seeing them as preventable. We can do something about them, and we can take steps to address them. Not only can we, but we should do. And when we talk about levelling up at the minute, these are the types of issues that should be considered. And there is a cost saving. From a report by the King's Fund, they found that every pound invested in preventing cold damp homes actually saved the NHS £70. So there's a financial incentive, not just a moral incentive for this work. The benefits of action, it's clear. We know it saves money. Now I'm talking a little bit about behaviour and what will trigger changes in behaviour. And firstly, for behaviour to change, there has to be motivation, the ability, and there has to be some triggers. And I would say first, if we're talking about behaviour change, that has to happen first at policy level, because it's only through supportive policy that public behaviour change will happen. So to make significant progress, the government has to probably change first, and that's something that's apparent. And the change in relation to, for example, EV cars by 2030, that's all very well to say that, but it also has to be, I suppose, made simple for people. As Robert said, if people are concerned about range and price, well, that it's simply not going to happen. So we're talking about the social and technological approach as well. We can get the technology, but if we don't combine that with the understanding of human behavior, we just simply won't come to an adequate solution. So we can have effective technologies, and they do have a huge role to play, but we also have to be successful in practice and how people will use technology in the real world. And the last speaker even talking about, you know, the jobs that will be created, the skills that will be necessary. That's what we have to communicate. And here within the ARC, before we had to do this, we decided we wanted to look at low carbon technology, and we did that, and we invested in it. We had the willingness first, then we had the technology. We invested in a pellet boiler system. Now that was complex and it was expensive, and it was very hard to get engineers or people locally that could work on this system. We also had the data, and that was replied to before. We had shed loads of data. We had any amount of data. We couldn't interpret the data. It meant nothing. So there is this understanding of linking between the industry, the academic, and also it's telling a story of what matters to people. And then we will achieve behavioral change. Keep it simple. With all of our programs, that's a mantra we use. We start very much with the children. Even when we're trying to influence health, we begin with young children. When we're introducing concepts about carbon reduction and why we need to preserve the planet, we start with children. It's very effective. The other thing that we have to consider is affordability influences choices. If you cannot afford the energy efficiency equipment or the low carbon technologies, you simply can't afford that. So your choice is dictated by your budget. We did very practical things through the Handy Heat project. We distributed low energy light bulbs, and we know that they are cheaper to run and they last longer, but they cost more initially. So that's a barrier to people using them. So we have to understand, I suppose, simple issues like that. We also looked at energy usage measurement tools. So people actually had that information. They could see how much it cost to boil the kettle. We also invested in thermometers and humidity gauges and readers because we know that cold damp homes, if we can keep one part of the home warm. But what we found is, particularly in rural areas, that one warm room was also used to dry clothes and all sorts of other issues that raised the humidity and caused a condition that was detrimental to children's health. And we have very high levels of bronchiolitis, for example. Our respiratory health in the west of Northern Ireland is very poor, and there are reasons. So we needed to recognize that. Also, we know visual representations of energy efficiency actually work, and there's evidence to suggest that the labels now that go on tumble dryers or whatever, talking about the energy efficiency, they do influence behavior. So things like that will help. And the holistic energy poverty offering, we need to be clear, what is that and how do we move towards it? We need remedial measures in Fermanagh. We have a lot of old stock housing. So that housing has to be brought to a level that if we introduce new low carbon technologies, that the fabric first is in place, that we're actually starting with where we're at this point in time. The low carbon technologies themselves need to be affordable, and there isn't incentives at this level in Northern Ireland at the minute that really encourages people to consider them. People that maybe have income and investment and in the longer term will get benefit, will move towards this technology, but poor people will not without support. So we need to consider that. Energy related advice and support, we need to tell people, we need to give them education and information, and that information and education has to be simple and straightforward and easy to understand, because if it's not, it simply won't work. For example, within healthcare, people can buy in Lidl anywhere really a blood pressure monitor, but if they don't understand what that reading is, it means nothing, and it doesn't preserve health. So we need to give relevant information in a simple way. And government policy objectives, and the current objectives we know that is to ensure light, power, heat and transport are affordable commodities for homes and businesses. So that exists. They provide energy scrutiny. They wish to reduce carbon emissions in order to mitigate climate change. So it needs to become practical and tangible. we had some really good, as part of our project, one of the things we looked is to define fuel poverty and then to look at case studies from other regions. And there's some really good practice out there, and I'm cited, so these reports will be available, but things that actually make it practical and tangible within communities, particularly rural communities, those examples exist. And I'm going to set a couple of them here for you to see. Very much local solutions to local issues, and beginning with what was considered in many cases to be a waste product in the area, and that became a resource. So rural solutions to rural problems, keeping them practical. And again, you know, from an engineering perspective, one of the projects we viewed in Finland, and it was a biodiesel plant, it looked like my dad's shed. It was simple technology and it was utilized in a way. We also have to consider risk in this country. We need to be prepared to take risks, and other areas that have been successful have done that. And national retrofit. Without there's a really good example in the south of Ireland about affordable, accessible, holistic, rural, multiple technologies at subnational level, and it's long term. So we need to consider those things. We can't just expect behavior to change without us having the, I suppose, the landscape to enable it. And key findings: it needs to be affordable, accessible, holistic, rural, multiple technologies. There's not one answer that fits all. Subnational partners, we need to be working collaboratively to share information, and it needs to be long term. There's not quick fixes. I know it's frightening when we hear that there's changes that are happening very suddenly, but the last speaker is quite correct. It will take time. And the conclusions again, our key objectives, we know what they are, and we know that there is low carbon technologies in a policy mix that's receptive. It's just making it happen at this point. Keeping it simple, ensuring vulnerable and energy poor communities are brought along through this process, because if we don't, and there are opportunities in every crisis at the minute, you know, we heard this morning of a 60% reduction in Russian oil that'll move to 90% in November. But we probably won't use that as an effort to consider new low carbon technologies. We'll probably just get fossil fuel from somewhere else, and price will exacerbate and become more unaffordable for rural people. So it's about really thinking long term and short term. And again, the solutions need to be non-prescriptive. They need to allow for adaptations to individuals, to the situation. They need to be rurally remote, and we need to consider dispersed populations and how we serve them as we move forward. This is the slide that I really want to show you today. We need to tell story with data. It's not simply enough to have the data, to sort the data, to arrange it, or to present it. We actually need to tell it. We need to explain with a story and tell a story using the data. And at present, we're nowhere close to that. So we really do need to consider that. What difference does it make to me? What difference does it make within my home, for my family, within my community? And that's where we need to begin to concentrate our efforts. And all the reports that I've outlined today and our full research can be accessed at the point below. I'm sorry I flew through that, but I'm just very mindful, Robert, of the time.
Oh, it was perfect, and really was, listen, it was really good, because you brought in some of the points that I'm finding now in the small pilots. So the key point you start off with, we need to look at policy levers, and we need to make energy efficiency a national infrastructure priority, and that's something we think is key. It has to be driven by a just transition. We need to keep it simple and tell the story. And a pilot we're presently doing now called Roulette, working with us university. We've got a householder whose sister is living in a house beside her. They both got the same house, except she got the energy efficiency works, she got the heat pump fitted. It's a hybrid with a gas boiler, and the tenant, her sister's got a gas boiler. Our tenants spending £15 per week less, and the two sisters are just bouncing off each other. And we're using that to tell a story, because that's very simple. That's a householder explaining, you know, it didn't make the factory readers were wee bit, not what I expected, and they couldn't drown the details, but now I get it. It's a constant low temperature heat. It keeps the house warm, and my bills are less than my sister's bills. And that tells the story. She's saving carbon. hopefully trying to save a bit of money and better thermal comfort, which gives better health inequalities. And you say the cost of cutting is clear. It's easy whenever we're talking about it. This kit's going to this house has cost £18,000, and it just goes back to our very first pillar. So we've got a new strategy looking at sustainable development. The first pillar is to deliver education and empowerment to deliver behaviour change, because without people taking it up and understanding it, but as you say, there has to be political levers, just transition to deliver that. But the people also have to have it in their home, and then they have to understand it. You just can't thrust technology at people. You have to be able to understand it, and you really brought that out very well, Jenny. So thank you very much. I suppose anybody has any questions, or anybody any questions for panelists, for Saku, for Charles, for Jenny? I suppose speak now. It's 4 o'clock. Or 2 o'clock even. Stone silence. Okay, counting down. 5, 4, 3, 2, 1. Well, okay, we've got no more questions. Thank you very much. Thank you for our 3 speakers. We now look forward to the final conference. The final conference will basically take all the key parts of the best seminar. So we'll maybe sort of coming at you again to come back to our final conference. 22nd of June, it'll be in Finland. It'll be a virtual conference again. It'll be a hybrid. So it's in around midday, so it is, but we'll have details coming out through the Eventbrite. But thank you very much for coming. Thank you for our speakers, for the team here, Stephen, Amy, and Maria, for making it all happen. And have a good day and be safe and look after yourselves. Thank you very much.
Thank you.